Hi everyone. So in this video, we're going to be talking about functional groups that we're very likely to see in this class. The first one we should be aware of is just very simply a carbon double bonded to an oxygen, and that's called carbonyl. C-A-R-B-O-N-Y-L, carbonyl group. And let's say the carbon has some kind of R group that is that's attached to it. And by R, we mean anything. R means anything that's not a hydrogen or oxygen. And let's say the carbon has another bond to fulfill its octet rule to an OH. This is called a carboxylic acid. If, on the other hand, we had our carbonyl bonded to an R and then an OR, so the oxygen is bonded to some kind of R group, we would call this an ester. If our carbonyl group was bonded simply to a hydrogen, we would call that an aldehyde. And if the carbonyl was bonded to two R's, so let's say R and R prime, we would call this a ketone. Okay, so these are the four basic carbonyl functional groups that you should be aware of. Carboxylic acid with the OH off of the carbonyl, an ester with an OR, an aldehyde that has just an H, and a ketone, which is just an R carbonyl R. So let's go ahead and erase all this. And let's go through these more quickly. So if I say we have that, I hope you said that that is a carboxylic acid. If I said that, that's definitely an ester. If I said, whoops, if I said that, that would be an aldehyde. And if I said that, that's a ketone. So let's go through them a little bit faster. That's an aldehyde. That's a carboxylic acid. That's an ester. And that's a ketone. Let's try again. Ketone, ester, carboxylic acid, aldehyde. And one last time. I'll just draw the structures out and you say them to yourself. Like I won't give you the answer. Okay, so now let's add a little bit more complication. If I said we had something like this, what would you call that? So hopefully you're able to see that all of this stuff right here, this CH2, CH2, CH3, is nothing but an R group. Remember we said R is anything that's not an oxygen or a hydrogen? And this stuff right here, the CH2, CH3, that's bonded to this oxygen, that's just another R, or R prime, however you want to think about it. So what I drew here was an R carbonyl OR. So what we drew was an ester. So R's literally can be anything. I can have something that's about to look like an aldehyde, and I can put a ring structure here if I wanted. All of this is just an R. So this structure is an R carbonyl H, which is an aldehyde. So hopefully you said that this is an ester. Okay, now let's talk about two more groups. These groups may or may not have a carbonyl group inside of them, but what they do have is nitrogen. Okay, nitrogen. So this should pop out at you if you were to look at a chemical structure. The first one is, let's say we have an NH2, and that's bonded to a carbon, or really any atom, that has a double bond. And we'll just say that that's an R group hanging off the carbon. This would be an amide, A-M-I-D-E. What if, on the other hand, we had our nitrogen, and that was bonded to a carbon, and that carbon had only single bonds, like let's say it was a methyl or something, just H's. This would be an amine. So here's how we define it. The carbon, that's nitrogen's neighbor. So in this case, it's this, I'm sorry, the atom, that's nitrogen's neighbor. So in this case, it's this carbon right here. And in this case, it's this carbon right here. So when nitrogen's neighbor has a double bond, we call it an amide with a D, D for double, okay? But when nitrogen's neighbor has only single bonds, we call it an amine. So it's almost like the nitrogen is not really all that important in naming these things. You have to look at its neighbor to figure out whether or not we're dealing with an amide or an amine. So let's practice a couple of structures. What if I had so hopefully you were able to identify that this carbon right here is nitrogen's neighbor, and it has a double bond to the oxygen. So this is an amide or amide. What's that? Well, that's a cycloalkane ring, right? These are all carbons right here. And they have hydrogens that I just didn't draw because I drew a line bond format. And one of the positions of the ring is a nitrogen instead of a carbon. So I'll draw it again. So all the carbons, so nitrogen's neighbors, this carbon or this carbon, they all have single bonds. So this is an amine. What if I did that? This would be an amide because one of nitrogen's neighbors, this carbon, has a double bond on it. How about this right here? So nitrogen's neighbors don't have a double bond. Here's a carbon and there's a carbon. They all have single bonds. So hopefully you said that this is an amine. But that this part over here was a carboxylic acid. Because all of this everything I'm highlighting in blue, all of this is just an R group with respect to the carboxylic acid. So see, the R group is that entire cyclical ring structure. And let's try one more. So hopefully you were able to identify that this part right here in our structure is an amide with a D because one of nitrogen's neighbors, this carbon right here, has a double bond. So that makes it an amide. And the other part on the molecule has a carbonyl that's bonded to an O something, which we're going to say is an R. And then it's bonded to this part right here on the left, which is all this entire ring structure, which is just another R. So everything in yellow is an R, carbonyl, OR. So that would be an ester. So the pink part of this molecule is an amide. The yellow part of it is an ester. So those are the most important functional groups I'd like for you to be aware of. Oh, and don't forget, we haven't looked at this one in a while, but what if I did this? So hopefully you said that's a ketone because we have a carbonyl right here. All of this is an R. And all of this is just an R prime. It's a different type of R. So all we drew was R carbonyl R. Okay? So those are the most important functional groups that I feel you should be aware of, and you should be able to identify if you're given any kind of structure, like it should pop out at you. All right, so let's stop the video here.